So this is a Zenith Chairside radio. You can see there's a little bookshelf at one end of it. And it's got the speaker over here. Cabinet needs some work. Missing a knob, and these two are incorrect knobs. Dial is damaged, unfortunately. Looks like it's missing. There should have been a surround that goes around this. That's missing. Doesn't look bad though. So, see what we can do with it. Cabinet is obviously apart, which is fine because refinishing it will need a little bit of space to work, so that's fine. So take it apart and see what it looks like inside. Here's the Zenith. It's a 5S237 chassis. Tuning seems to work. Volume switch. So, cleaned up the tubes a little. Not terrible. Speaker is in poor condition. It's warped. It's frozen. Mostly warped. Cone is shot. We have a little bit of a problem. You can guess what problem we have. Take a look. We're going to put these on. Hard to do with one hand. So this is the output transformer. That's about right. Now we're going to do the field coil. Nothing. Field coil is bad. Unfortunate because it is a Zenith speaker. But between the cone being bad and the field coil being bad and the whole cabinet not being that nice, and the missing piece, I'm just going to put another speaker in it. I have several of them, although I'm using my stock of speakers pretty quickly between the Emerson and this. So let's see what we find under the chassis here. Here we have underneath the chassis. You can see someone put a very large capacitor in here. This is a, what do we got? 40 microfarad. Good thing there's only supposed to be 10 or 8 or whatever. This is a 16. And then we have, what is this? This resistor down here. This goes, where does that go? That goes between the field coil. That's weird. So maybe someone knew about this problem, was trying to bypass it, and then figured out that it just wasn't worth fixing. Got this candle, I'm just going to measure it here. Okay, so that one's good. That's the first part. Let's do the second part. Okay, that's all right. Get the third part here. Okay, so that's not open. So that's one potentially good thing. Let's look at the schematic, see what that looks like. Okay, here we have the schematic for the Zenith 5S237 right here. Let's take a look. The speaker field coil was supposed to be 1250 ohms. Okay. You have your first filter capacitor. This is the positive here. This is negative. Now note, the negative does not go to ground. I'm going to have to check that. The negative should not go to ground. You got your Yeah, so this is the can dome, which we've determined is good. This here, this is the field coil. So you've got your first filter cap, that's C15, which according to this, C15 is 8 microfarads, and C16 is 14. So C15, which is the first filter, 8, 14. So clearly 40 is a little optimistic as far as values. Now, for this to fail, this field coil, usually means there's a short on the second half of the B plus line, right? So typically this filter cap, C16, will have shorted or been extremely leaky and causing high current to flow through this field coil, and then it fails and your radio doesn't work. So what I'm going to do here, I'm just going to do a little markup here. So we're going to trace the B plus. So we've got B plus coming in through here, B plus going up through here, up through to C13. So that goes there. Then it goes here. Oops. Goes here up to this resistor. Then it goes here to C6, goes here up to this coil, goes here, again up to this coil, back down here, and to R3, continuing all the way over here to this band switch. Now this band switch is also a tone control. So then it comes here, goes all the way here, goes back here, up to C14. So that's our B plus line. Now, for this to have failed, something on this line shorted or was leaky. So you've got this being the highest probability. It's possible C13, although if C13 shorts, usually you lose your output transformer, and that tests okay. So it may not be C13, but it's possible. Oops, I didn't mean to do that. You've got C6, so C6 could be shorted. That's possible. And remote possibility is C14. So most likely C16, could be 13, and could be 6. So I think the first step is to replace these electrolytics with the proper values. So this is kind of interesting. This is why you don't want people who don't know what they're doing working on your radio. First filter cap connects here, okay? They put a resistor right here. Fine, resistor will work just like this field coil. Problem is they kept this field coil speaker. It's not going to work because there's no magnet in here. It's just a coil, and if it doesn't get any electricity going through it, it does nothing, and there's no magnet, so the speaker won't work. Anyway, put a resistor here, thinking they were going to solve this problem of the open field coil. Then they attached the second electrolytic. You can see the wire kind of goes from here to here. That's fine. So that's the second one, right? Now they put the ground, look at this. This is the ground. Look where the ground's going. It's going down here. And down here is this terminal. Now let's take a look at the schematic. C15, negative goes to this terminal. C16, negative goes to that terminal. Clearly it wasn't working, so they went back and said, okay, let's put another capacitor in, connect the negative to the same place, And the positive to here, where's this positive? Positive is right here. Right here. So look at this. This is what they did. This is how crazy this is. So they don't have a connection here. They took this and put it over here. Okay. Sorry, I can't really draw with this. It's very hard. That's what they've got. Now, didn't solve the problem of the hum, I'm sure. So they took a positive here, and they took this here, and they went around to all the way up here and to here. Look at that. That's what they did. That's wrong. Very wrong, in fact, because what this does, this creates a negative bias. So it sets the bias for the audio tube. So I wonder how good this audio tube is. It's probably shot. We're going to test that. But first, I've got to fix this problem. This is nightmare. I changed the capacitors. You can see I put them on each side of the field coil. Negative of the first one goes to here, which goes to here. The second one, it's right here. I'll put this positive here. Negative goes here, which is really here. So that's the correct positioning of them. Now, I have one of these resistors, my last one. It's a 1.2K. Apparently I need to get more of these. I'm thinking I can kind of fit it between here and here. Kind of just sneak it in there. It should get a little warm, but it should be all right. It's kind of tight. But once I do that, I won't be able to reach down to replace these other capacitors. You got this one here, one here. So I think, you know, probably just change them. So I changed all those capacitors. That would be hard to reach once I put this resistor in. Next step is to try and clean up this terminal down here. I think that may be, let's see if I can zoom in. Yeah, that may be a little hard to do, but I'm going to try it. And then put that resistor there. I know it doesn't look great, but there's our field coil, well, sort of. So we get that in. Now, I think what I'm going to do is look at the schematic, figure out what do we need to change. So definitely changing C12 before I power it up. What else? Oops. Do that. So I'm definitely changing C12 before I power it up. Any coupling cap, I'm in C9, that doesn't really matter. Most of these are bypass. Yeah, so that's C12 is really the only critical one, so I'll probably do that, and then we'll power it up and see what happens.